Just kidding. I am? You're being sarcastic.
No, definitely not.
I think my future really is to be a demotivational speaker. I'm pretty good at it. All right. I'm better at it than any of you will ever be. Okay. Ready? Seth, I'm not going to play the song anymore. 3 games in a row of no one doing anything.
Okay. I'll talk to you later because I have a plan. That think about for like 2 days.
Okay, because I just feel stupid. Like I put it on and everyone's like, and half the speakers on the student side are blown out right now. So you can't really hear it without me connecting. And that's just hard to connect to that in the 10 seconds after they shut it off and I have to do what you want me to do. Okay, here we go. Today, partial pressures, which are not too difficult. They're not that bad. Okay.
I thought you said we're going to learn something that was not even.
I did? No, you said let's learn something completely different. So I said, okay.
Oh.
All right. So
I'm sorry, guys.
here we are. This is Dalton's law of partial pressures. It is actually one of the standards on the AP thing that we read earlier. Like it will be assessed. And it's super easy. It says the total pressure of a mixture of gases equals the sum of the pressures that each would exert if it were present alone. So what? It's just addition. Now, of course, we're in AP chemistry, which is AP pain in the butt. So it's harder than that. But it really is just saying it's addition. What it's really saying is something that most of us don't realize. And that is if I closed off this room and we sealed this room and we pumped it full of some other gas besides what's already in here, the pressure of the air is going to stay 1 atm. It will have 0 effect on the air pressure. It will have a huge effect on the pressure of the room, but of the nitrogen and the oxygen that are in the air, they're going to stay constant. The pressure of a gas is independent of any other pressure. And we actually took advantage of this yesterday while I ate a cookie, because we had multiple gases in the same container, right? And I said, don't do 3 Pivnerts, just add all the moles together. Because the total pressure depends on just the moles of the total moles, but the pressure of each individual one just is determined by how much of it there is. They do not interact with each other. Go ahead.
So pressure is like directly related to moles. There's like,
Yep, because P, we'll just do the whole thing, equals nRT. So P and N are on the same like plane. It's not, there's not one of the denominators, so they are 100% directly related. Okay, so far sorted with me. It gets trickier very quick, but it's not terrible. Okay, there's a lot of stuff on this slide. You can write as much or as little as you want, but it will help us do a question like this. And these are real common on the AP test. So it says, each gas in a mixture of gases, I typed this, so there's probably some spelling and other issues, whatever, behaves independently of the other gases present. Therefore, each gas in the mixture obeys the ideal gas law. Treat each of the gases separately in the mixture. See, that's really well written by Tom Davidson. 4 equations govern the treatment of partial pressure equations. And sometimes you have to use all 4 of these in one particular problem. And that is Dalton's law, which means the P total, there's not a negative, that's a dash. It was just, I regret ever putting dashes there, but whatever. It says that the total pressure, or P total, is the sum of all pressures. So it's really easy. If I want to know the total pressure, That's how it's rewritten. And I know the three gases are 1.1 ATM, yada, 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 yada. I just add them and that gives me it. They're very easy problems. And sometimes you get them. All right, mole fraction. It's the first time we've done mole fraction. Probably is. It's not bad. The mole fraction is basically finding its percentage without multiplying by 100. You take the moles of the gas you want and divide it by the total moles in the mixture. You've done that a lot. We've always like found a percent composition. It's the same math without multiplying by 100. We take the part we want and divide it by all the parts. Okay, that is represented by a capital X. And this will be important because we get to number 4. Number 3 is the ideal gas law, which we're used to, PV equals nRT. And number 4 is how we find partial pressure. And usually this of partial pressures, finding partial pressure is the main one that we do. But it takes all of them to kind of put it all together. I didn't like that color with the red mark. Partial pressure, if you want to know the pressure of just one of the gases, we find its mole ratio and multiply it by the total pressure. So another way of saying it's mole ratio, we find the percentage that it is adding to the total N and multiply that by the pressure. Anytime a mixture is given in the problem, you will need to use these equations to solve. So here is an example. And by the way, most of the time in real life, we don't have a pure gas. We have a mixture of them. Okay, so here we go. We have a practice problem. A mixture of 9 grams of oxygen, 18 grams of argon, and 25 grams of carbon dioxide exert a pressure of 2.54 atm. What is the partial pressure of each gas? Okay, so we want to solve for partial pressure. So I need number 4 because it says partial pressure equals, all right? But in order to find partial pressure, I need the mole fraction. And then I know that P total is 2.54. So the steps are not awful. You convert all to moles. Divide. Well, okay, there. That I don't even know what happened in my brain right there. Each mole by the total. And that will give you the X for O2, the X for argon, and the X for CO2. So the first thing you got to do is just divide by their molar masses, right? All right. Does anyone have 9 divided by 32? 0.281. 0.135.
125.
Is this 0.45? I did that in my head. And I didn't do this one in my head.
0.56818.
All right. Now, those are the moles of each one, right? So the first thing, convert all to moles. Next is to divide each mole by the total moles. So we need to add these three things, and that's going to be my denominator 3 times. All right, anyone have a total? 299. All right, I already wrote the 2, so I'm committed. 1.299. We okay with that? Now I'm kind of out of room, so I'm going to just come down here. For oxygen, I'm going to take 0.28125 and divide it by 1.299. And that'll equal a number. For argon, take 0.45 and divide it by 1.299. All right, for carbon dioxide, 0.56818 and divide it by 1.299. No, that's not far enough over. All right, for oxygen, when we divide a 0.28 whatever by 1.299, what did we get? For argon, all right, for whatever this one, carbon dioxide, 0.427. This is just so ugly the way I did this, but you'll live, I hope. Okay, so where, I heard someone mumble this, I'm sure more people have this question. Where did 0.254 come from? That's the total pressure at the start. So what we did number 3, we found the mole fraction first. That's when we did the moles and divided by the total moles. Once we had that, that gave us X for each individual substance. So then we took X and multiplied it by the 2.54. And all right, so Blaine, for oxygen, what did you get down here?
0.55.
Okay, how about here? Okay.
1.11.
Okay, those would be your ATMs. I would always, if I had time, I would double check. There's a way to tell if you did this right. You add them, and they better dang well equal 2.54. Or like within a 10th or 100th, I mean. Okay. Oh, not bad. I mean, it's AP chemistry, so it's busy work, but it's manageable, I hope. Who feels all right about this? Okay. Here's another one exactly like it. Try this on your own. We'll see how things go. I'll save you, well, you don't really need it, but nitrogen's 28. No, sorry, it's 14. No, yeah, it is 28, sorry. I just was thinking of the wrong number in my head. It is 28. Neon is 20, and carbon dioxide is 44 again, right? All right. I'm gonna eat a Tootsie Roll so I can get the pepper out of my mouth.
Snack during this class.
Yeah.
Perhaps lunch, like,
My lunch is underwhelming because I'm on a diet.
and diets only count during the base meals of the day.
Right. No sugar in this Tootsie Roll.
Probably true.
I say sugar and you think of Isaac? It's rude, ma'am. Oh, what a trick question. What a guy. No. I do that at home though. All right, we good?
Wait.
Oh my, wait.
I forgot a step. Hold on.
That's all right. They'll wait for you on the AP test too. That was aggressive and she didn't even hear it. Ooh. This is how you know I'm on a diet. What have I been drinking lately?
Water?
Water.
There's Mountain Dew in there. There's so not.
There's not that.
What's your diet goal?
I drink water with you.
I got to get back under 200 pounds. It's not that bad. I'm 12 pounds away.
Lost 7 pounds in like a week.
Yeah, but I'm not, that's not sustainable. I lost like the easy fat. Then I got to start running. Stupidest thing ever. No, it's embarrassing. The last time I ran with cross country kids was forever ago. And I went to the Honeyville 5K and I used to run pretty decent. My PR is a 17:45 in a 5K. Like I was fast, but that was 30 years ago. I ain't fast no more. It was also 60 pounds ago. That's the main problem. So anyway, yada, yada, yada. I picked this kid at cross country I know, and I'm like, oh, I'll just run with Stan. He's probably medium. Yeah, Stan Bound. He was not medium, not at all. So I run with him like for a minute. I was like, oh, very bad decision here. And so I slow down. And anyway, I get to the first water station and I am dead. All right. So I'm getting some water and Kelly Mariano is running. She was Kelly Olson back then. She's like, hey, Davison. I'm like, oh, crap. I just got passed by Mariano. And then a mom pushing a double wide stroller passes me. And I'm like, I'm never doing this again. That lady did beat me, by the way. It was pretty rough for my pride. I can run with Rollins. I just don't want to. I look better when I run than Rollins, by the way. That's about it. All right, are we ready? Ooh. You're stuck? Well, hopefully I will unstick you. 20 grams of nitrogen. So I take 20 and divide it by 28. That's easy. That's 1014. So that's 0.7, isn't it? 7.1? 7.1. We'll go with 714. I've just always thought that was interesting math because I'm weird. Because it's really 10/14, right? And what are the odds that 10/14 equals half of 14 and another 14? It's okay if you didn't get it, but whatever. Okay, 18/20, that one's easier math. What's that one? Everyone should be able to do that in their head. 0.9, because it's 9/10, right? All right, 20 over 44. 10, 20 seconds. 511, 0.455. Are these the answers? We're not even to the, they're not even the second thing before the answer. Yeah, we just barely, thank you, just barely put our toe in. All right, so now we take these numbers and divide them by the total of each one, right? Of all of them, I mean. I'm just going to do it right here. It's going to be ugly, but I'm going to divide each of these by the total amount of moles. What's this denominator? 2.0659. That's a 9. Dave, so I'm worried about you the last 2 days. I feel like you're chemistry pressed. All right, we ready? What's the answer to this piece right here? 0.0 what? 345? Okay, let's just address something in Tom Davidson's life. I never say 0 point anything. It's been a long year. It's taken me till January to be like, just don't give me a 0. Timmy and every other one that had better teachers than I did, because they're right. I don't care. Goddard, then it's even worse. We're never saying a 0. I refuse. Okay, here we go. So this answer is 0.35. Okay. This answer is point what? That's my area code. And this one is 219. 0.219. Is that the answer? No, we're at least in the water now. But we got to do what for each one of these? Is it 5? 3, sorry. Okay, here we go. This answer is 1 point something probably, right? 1 point what? Okay, this one is 1.305. Imagine your dyslexia if you had that and that and this and that.
It's worse.
You just rounded up.
Yes, Seth.
So, so I got different answers, but it's still rounded up to 3. That's still like, because I just rounded it differently at the beginning.
It's okay, probably. Probably. How far off were you?
I just got 3 negative 308. The difference was the 0.455. I did 0.45. I didn't do 0.455.
Oh, it's fine. I'm not that stressed. But I would typically, to be safe on the AP test, I would use at least 3 decimal places in your math. All right. What do we have here?
0.66. If we do 66, then the math works out.
Okay. Okay, so I don't want him to feel great. So are these our answers?
Yes?
They better be.
All I did, so.
Yep, there you go. And then we'll divide by the square root of 1 and then square it. Okay. These are not the worst things we've ever done, right? Sounds good to me. 2.997 is pretty good. That's close to 3. That doesn't open, but that one does. Okay, how we feeling? Good. In the first time in forever, you got the first practice problem right. I started too low. I apologize. Was anyone at the game the other night when we sang happy birthday? Definitely started that one too low also. Yeah, it was a disaster. I warned them though. Tone deaf baritone. It's a bad combination for someone to start a song. Okay, here we go. AP, this is from the AP classroom videos, which I don't think anyone's watched, because why would you do something that would help you do better? All right. It's okay. I don't floss every day. Yeah, right. You're not going to think that on May, whatever. You're going to be like, oh, I should have watched the videos. Here we go. Think this one through. Watch this one or read this one through and see if you can answer it.
What does it say the pressure of the denon wire?
It does not.
Oh,
You asked me a question though that could answer that. You okay?
what are the circuits represent?
Xenon atoms.
Wait, I haven't come to these papers, right? So don't-
You've paid a little bit for it. I think so. You better have.
I don't think I paid any.
Okay, never mind then.
I was like, I have not paid any.
I don't pay attention to any emails I get from Mumford. That's your job.
Oh, boy. So wait, when did I?
Okay, it doesn't matter. Focus on this. Focus on this. If you are registered on AP Classroom, which was everyone except for Isaac and somebody else with 2 days to go, then you have a test ordered for you.
Oh, really?
Yeah. Yeah, we have 3 tests that will come unless those 3 kids talk to Mumford. I emailed him, but he may not remember. Focus. Do you know the answer, actually? I got one very confident yes from a male. Okay, I wish I had a like a response system right now.
Yeah.
I have one, but it's like 30 years old and doesn't work anymore on this.
So we have lit temperature. That's like really close to a vacuum.
Well, yeah,
Each of those circles
the way that's
represent
drawn.
an atom. Wow.
All right, here we go. We ready?
I am really
B, just at least give me an answer. Who says it's A? Not a single soul.
Wait. What's
That's
my
a-
favorite letter?
Who thinks it's B? Two of you. All right.
I didn't actually read the problem all the way.
Who thinks it's 3? Raise your hands. You raised your hand twice.
I haven't listened. He thinks it can be both numbers. It's like 2.5.
Okay. Then who thinks it's 6? That must be everyone. Okay, that is correct. It is 6.
Hey, I was only like
Okay.
4 off.
Okay, here's why. Here's what we know. We know this is 2 ATM. I swear I selected that. We don't know the pressure here, but pressure is directly related to the amount of things, right? So there are half the amount of things. So the pressure here is 1 ATM. So the total is 3, but then we drop the volume in half. So you multiply it and it gets 6.
Okay, that makes sense.
So I was half right.
This one?
Related to the amount of things. So
We know that 6 made a pressure of 2. Same size, same other conditions, or it would have said they were different. So it's half as many things. So N is half, so P has to be 1/2. So we have 2 plus 1, but half the volume, so it became 6.
oh my goodness gracious.
2 plus 1 is 3,
Something was wrong with these numbers.
but we take half the volume. So we have to double the pressure. Hey, I got a question. Do I want to ask that?
Yeah. How was that?
How'd you like it today?
How come on the top I didn't say the volume was 4? Because they're separate and it's 2. Okay, they were not combined in any way. They are later and that affects it, but they were 2. Okay, this way. Don't worry about what that said. That had nothing to do with your lives. Gosh, someone died inside even though it has nothing to do with you.
Tim had a like mental breakdown the other day.
Timmy's one of my favorite people.
He
So
was like, he walked into our culinary arts class and he was all like,
everyone else look while she's telling me a story. Culinary arts class.
he walks in and we started the bistro today and he's all like, I'm sad. I don't get to be in a group with you guys. Normally like we were in a group, us 3. And he's all like, and he just walks away and we're just like, this
Here's the depressed Tim look. I'm depressed. Here's the happy Tim look. Here's the Tim at the end of a 5K. A little bit more red. And the hair's not quite as perfect. Anyway. Okay, how we doing? Why are you distracted? Me? Someone's listening.
I can't.
The figure below left contains seal, but it contaminated molar weight 44. I didn't even crack her. I tried. I was just trying to confuse her because I'm a good teacher. All right, here we go. Here we go.
Wait.
Oh, wait. Thank you. Okay. Who thinks it's less than 1 ATM? A? All right, we got Tim. Oh, we got the girls in the front. Okay, who thinks it's B, that it's 1 ATM? That's a lot of people. That would make me nervous. Who thinks it's C?
It's actually both at the same time.
Can I go for all four?
Who thinks it's D? It cannot be determined with information given.
It can't be determined by me.
All right. The answer is, it's the same.
Let's go! Let's freaking go!
Okay, the pressure is 10, or sorry, it's 1. And pressure is directly determined on the amount of things there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doesn't matter.
Everybody hits their back.
But there's the same amount of height matters, right? Because
Hey, so everyone talk less and listen more. We just said in the previous one that the pressure is dependent on the number of things, right?
Dude,
Quit talking, everybody.
I'm so sorry.
No, I don't.
you have to sit on your desk to get out of here.
If there are 10 things here and 10 things here, then the pressure remains the same. We don't care about their size for pressure. Now we will for the next part of the question. Oh, it doesn't even ask it. I guess I have to fast forward the film further. He eventually goes on to ask a second question. And he says, which container or which sample has the higher density? So talk to your partner, which one is higher density? Now the options are that they are the same, sample A, sample B, and I don't, maybe the fourth one is probably cannot be determined.
If they have less things in the second one, then if we have less, that was the worst thing.
It depends.
Wait, what am I doing?
Do you ever feel like you send out messages in the group me and just no one pays attention? There's one person in here wearing purple that's not on student government.
I literally don't own any purple.
Not,
Oh, no, I was like, I just got hurt.
I've got purple on.
thanks, Bill.
I have purple.
Thank you.
I have a pencil that's purple.
Rockettes used to have to wear purple on Friday.
I almost did one.
Okay,
There's purple in my water bottle.
here we go. I feel bad for my man Seth because he's like Thursday night, he's ready. He says, hey, everyone, this is in the leadership. Okay, we're at 4. We're in the leadership one. And he says, hey, well, 5. Will everyone remind your classes that there's Purple Friday? And then he hits up the junior one. Hey guys, like super friendly Seth, like let's all wear purple tomorrow. And then you just stab him one tiny knife at a time in the back.
I feel like a horrible person now.
You should. It's Seth.
Oh my god.
Maybe I'm the distraction in the class. Okay, here we go. Who thinks it's sample A has a higher density? Sample 1, sorry. Who thinks it's 2? Who thinks it's the same? Just kidding. The answer is sample 1. And here's why. All of the molecules here have a mass of 44 grams. 2 of the molecules here have 18 grams. There's slightly less mass in the same volume here. Yeah, you need it. You ate like a whole pizza right in front of us. Okay, well, whatever. Okay, are we all right with that answer? If it asks density, just do the math, mass over volume. Okay, here we go. This one I didn't really read. Remember when I said, "Ooh, nice question" or something like that? I was reading this one thinking, "Oh, you sly dogs." Okay, here we go.
Oh, that's kind of like Corbin was like, "Are you watching your own video?"
Yeah, I don't remember what I said. It's not even remotely hard as long as you read it. You gotta read it. It's dumb. All right,
Oh, oh.
here we go. Who thinks it's A?
Never mind, you guys told me wrong.
Who thinks it's B?
Confused by it.
Who thinks it's C? Okay, who thinks it's D? That is incorrect. You were
I was so excited.
you were so confident. You're like, I'm going to be the only one right. I'm wrong. The average kinetic energy remains the same. Read. The temperature is held constant. Yep. So this will give off heat, but they must have some way to maintain that. So this is really a vocabulary question. Checking whether you know that temperature and average kinetic energy are the same thing. That's all that's asking.
I remember.
There you go. Okay. I don't know when the test is, but it's not very long from now. It's coming. It's coming. Okay. This is something that will be on most questions from now on. It's not bad. So it's the partial pressure of water. And what it's saying is in a closed container, okay, this is the lid, you have your water in here. And no matter what temperature you are, except for like 0 when it's a solid, there will be some water vapor up here. Not a lot. And the colder it is, the less you'll have. The hotter it is, the more you have. But you'll have some gas water vapor above the liquid. And it's called the vapor pressure of water. Okay, so whenever we have a reaction or a pressure measurement when there's water, we have to account for the vapor pressure of water. So to find only the pressure of the desired gas, one must subtract the vapor pressure of water from the total pressure. So it would say, like the problem, it would give you that the pressure is like 771 torr. And it'd be like at, I don't know, 38 degrees or something like that. Okay. And then you would have to look in a table. And the table would have temperature versus vapor pressure. And you'd find like, this is stupid how I wrote this, but you'd find 38 degrees and you'd find it's like 35.6 torr. That's a 3. So in this problem, if it asks you the pressure of some other gas, you would subtract 35.6 before you did any calculations, because there is extra gas in there called water vapor. They're not hard. They'll be given to you in the problem. And most of the time in the problem, it doesn't want to give you a full table. It'll just say the vapor pressure at 38 degrees is 28 point whatever torr. And that's your red flag that, hey, this is a water vapor question. All right, let's see here. So when one collects gas over water, there is water vapor mixture in the gas. The pressure due to the water vapor must be subtracted out before you calculate any PIV-NERT values. So when we did our lab the other day, we had our tubes. They were full of hydrogen gas, and there was also some water vapor in there we needed to subtract. So you might think, hey, that's why we were way off. No, it's not. I still don't know why. Because we're like 50% off, and the water vapor is like 2% of the whole problem.
You just said it that.
Maybe I just suck at teaching.
No.
Thank you. There we go.
We're all just in shock at this point.
Oh, you were?
Yeah.
You were like, hey, it's about time you figured it. All right, so whatever, we just said that. So here's a typical table, and here is an easy example. It says 109. I got this always makes me laugh. I'm sorry. It's gonna make one of you laugh. It's gonna make all of you laugh if it's on the AP test. because I've never graduated from like being a 12-year-old. Very, very often it will say this. No, this is hard to put, but gas collected over water is often called wet gas. So
No.
it'll say like 193 milliliters of wet oxygen gas, and that whatever, and I chuckle every time I read wet gas. And now you will, because I ruined your life. And so Rosie, she'll be doing the AP test. You'll start chuckling. Quiet. You're like, but the test has wet gas. How do you not laugh? Wet gas means it has water in it. Okay, moving on. I'm sorry, I'm 12. Okay, here we go. 193 milliliters of O2 was collected over water on a day when the atmospheric pressure was that. The temperature of water is that. How many grams of oxygen were collected? To get grams, we need N. That's how grams and PIV-NERT relate to each other, right? So we got to solve for N. If PV equals nRT, then N must be PV over RT, right? But what do I do with this number right here, the temperature? You don't need to put it into Kelvin. Like, yeah, I guess you will later, sorry, you will. But first, we go to the table. 23 degrees Celsius is right here, and the vapor pressure is 21.07. So you first, before you do anything, you take 762 and subtract the water vapor, which is 21.07. And that is the P value you use in PIV-NERT. So 740.93. Okay, then I feel like you can do the rest. That's your pressure. Use that and all the other values it gave you. And Tim was right. I cut him off early. You do need 23 into Kelvin. The temperature of the water and the temperature of the gas are going to be the same value. No, 2-1.
2-1. Close. Radical today. Huh? Oh, crap nuggets. Wait. What number is that? What number is that? Oh no! I give up. I give up on life.
Sorry, that's not funny. Do I have all those right?
I always.
That's the conversion from Tor to ATM. Pivner always has to be an ATM. If it gives you Tor, you always have to divide it by 760.
Right against me.
Nice job, Brown.
0.0821.
What?
Okay, I got like really. Which means I'm not right. Okay.
Okay, what did N equal,
I messed up again. I messed up twice.
Brown? What did N equal?
0.0077.
0.0077.
Holy crap.
Is that our answer? No. That's moles. N is moles. N is moles. So I got to multiply by the oxygen's molar mass.
How do I check so much?
0.24, is that what it is?
I
That
didn't
one?
know I could be so bad.
0.2464 grams. What? I'm sorry. This chapter, you're not loving it, are you, so far? Sorry, my man. There's a lot of pitfalls along the way. That makes me want to play the old game called Pitfall. 700 and, yeah, I do. Okay, 0.264, 2464, who had it right? 1, 2, 3, 4, 5, 6, 7 and a half. Did you have the right answer?
I was 0.0013 off.
What?
I was 0.013 off.
Nice. Nice.
Calculator.
Okay, it's going swimmingly.
As always.
Yep, 5 people get it right. I feel pretty good about that.
In my defense.
Did it right.
Okay, tomorrow, we're gonna start with this problem again, but we're gonna do every part of it the right way. I'll change the numbers so that it's different. It'd be different anyway, but I'll change it anyway.
So we're blowing things up in the flaps again.
No, we're not doing this. Oh, well, yeah. But like we're not physically going to do it.
Is this practice?
This is the same problem you did while I ate cookies. But you're doing all the parts the right way. Yes. Because it wanted the grams. And the molar mass is 32 grams per 1 mole. Yep.